Hey, hi everyone. We're going to work on some questions on the review. So let's see. So question number 13 here. It says, use a shell method to find the volume of a solid generated by revolving the region bounded by y is equal to 7x minus 6, y is equal to the square root of x is equal to 0 about the y-axis. Okay, so a couple things we can figure out. This is a line, -6, right? Let's go with that being -6. A positive slope of 7. We have a square root graph right here that looks something like that. And we're going to rotate it around. Oh, x is equal to 0. Here, so here's x is equal to 0, right? So hopefully you guys can see the shape. Let me go ahead and highlight it in yellow for you guys. That's my shape. That's bounded by those graphs. And then we're going to rotate it around the y-axis going this way. Okay, so a couple things I want to make sure that you guys understand why we're going to use the shell method versus the, in this case, it would be a washer, right? Why would we use a shell versus a washer? It's because if I rotate it this way, right, going around this way, we would have to, sorry, around the y-axis, this is our problem. We're going to be outer, inner, and see how the graph actually changes on this lower section? Sure, on the top it might be outer. We have an outer section, and then we have an inner section. Sure, that's a washer for sure. But then the equation all of a sudden changes because we lose that inner ring. So this equation, if you have done it using the washer method, you would be something like -6 to 0, and then from 0 to some number. We have to figure out what that number is. We can figure out what that number is right now if we just solve it, setting the y's equal to each other. Where do these intersect? So on the test, yeah, fine. Square root of x equals to 7x minus 6. If I square both sides, it'll be x equals to 7x squared. Whoops, what am I doing? It'll be 7x minus 6 squared. I think it'll be easier if we just find out where they intersect, right? But let's see if we can have to do this manually. The y's, yep. Okay, so we have 49 x squared minus 6 times 7 is 42. 42 is 84. X plus 36. And then 0 is equal to 49 x squared minus 8x. Oops, sorry. Plus, darn it, minus 83x. Oh, sorry, 85x plus 36. Now, I don't know how to solve for that, except using quadratic formula. I don't know it's factorable. So if I just plugged it into a calculator, the problem is I'm trying to figure out is, oh yeah, weird decimal. Did you try dividing by pi? And that should give you maybe an easier number to look at. Because when we revolve, there's a pi in the problem. Let me see. Actually, you could also do the integral on your calculator and just not write pi in there. Okay, now real quick here, that I don't know how to solve. I mean, I could use quadratic formula, but instead, let's go ahead and graph that real quick, see what that looks like. We'll use Desmos. I was hoping that it would come out cleanly, but it doesn't look like it's going to come out cleanly. So we have square root of x. On the bottom, we have 7x minus 6. And we can see that they meet at a nice 1, 1. Okay? 1, 1. All right. So that's 1, 1. Because we're still decimal. Okay. Let's see what happens for my version. So if I did my washer method, this would be harder. So instead, let's just go ahead and just do our shell method. Now, shell method, we don't have to change our x to y's or y's to x's. We just take it as it is. And I'm going to just instead draw a... Oops. No, come on, I'm trying to be... Okay. I'm going to draw a 1 cylinder here. Okay, that's my cylinder. Now, what's the equation for a shell method? It's 2 pi RH, right? Because we're finding the volume of a cylinder with a little bit of dx. So integral dx, and in this case, our radius is going to go from here all the way out. Okay, that's our x value. X is going to start off at 0 and it's going to walk itself out. And upper minus lower, you can see upper minus lower, upper minus lower, upper minus lower, upper minus lower. That's the height of our cylinder, and it's going to be our square root equation minus our line equation. The radius is just going to be x going out this way. That's just x. So we have everything we need. So integral from 0 to 1 of 2 pi r is x. Our h is our upper minus lower, which is square root of x, minus lower, which is 7x minus 6. Okay, let's see how this one came out. Okay. So if I enter this in a calculator, I don't have a calculator with me. If you multiply this out, it would still be kind of ugly. 0 to 1 of, this is x to the 3 over 2 minus 7x squared plus 6x dx. I think I did that right. 7x squared minus 6x. Without multiplying pi, right? 1/6. Yeah, if it's not a repeating decimal, I wouldn't know what it is. Let's do this by hand then. Let's see what we get. 2 pi. If we take the integral of this, is x to the 5 over 2, which is 2 over 5, minus 7 over 3, x cubed, plus 6 over 2x squared, right? So I'm just going to write 3x squared. And then we're going to plug in 1 and 0. So we know that if I plug in 0, it's not going to matter. So it's just 2 pi times 2 over 5 minus 7 over 3 plus 3. In this case, this seems like an ugly fraction. We're going to say it's going to be, common denominator is 15. So it's going to be 6 minus 35 plus 45 all over 15. Just combine those together. 2 pi, 45 minus 35 is 10, 10 plus 16 over 15 times 2, which is pi 32 over 15 pi.
Mr. Cole?
Did I make a mistake?
No, I just want that. So can't we just like plug in the first part in our graphing calculator to solve this, or no?
Yeah, you should be able to.
All
I'm
right.
just trying to figure
I
out.
tried doing that, but it didn't work for me. Weirdly.
Okay, so my answer here is actually correct. 32 over 15 from my problem worked out. If I type this into a calculator, let's see if I write the decimal version of it. Let me get a calculator.
I think I don't know if it was the question, but I think it asked for exact number.
Oh, you're right. Type the exact answer. And when they
So
ask
you
you
couldn't put decimal.
so if they ask you for the exact answer, especially on let's say this was an AP calculus question, this would not be a calculator question probably. This would probably be by hand, and you can see I could have done this by hand. So this was a by hand question. And the reason why they ask you for the exact answer is the way this testing software is created. You rounding off, let's say 2.133, their answer is legit, just 32 over 15. That's their answer. So anything that deviates from this exact answer is going to be wrong. That's why. So yeah, I would not have known what that fraction would have been, 2.133333329. I mean, you could have just started multiplying random numbers. Oh gosh. Getting up to 15 though. Okay. Sorry about that, Haruka. Okay. Are you guys okay with
you have taken the decimal and divided it by 100 and then like tried to simplify the fraction that it gives you, or no?
For instance,
It
Haruki.
had to work backwards.
So Haruki gave me this. So she did a calculator answer, and her answer was like 2.13333333299. So it started changing on her. Right. So if it starts changing on you, it's not a repeating decimal. So then it's hard to figure out what it would have been. Yeah. If it was like 2.1333, yeah, sure. Then you could have done something like that. That's right. You could have done something like that, but it wasn't that. Okay. Is that okay? Was any of this part that hard? Not really, right? So, okay. Next question. Number 16. If you guys did this already, go ahead and you can try these questions again, right? So right now with my settings, will they allow you to try the same question again, or it will not?
No, it gives you a new question.
Yeah, it gives you a new question, but you can practice that new question, right?
Yeah.
Okay, cool. Now for the test, make sure you do show the work so I know that you're doing the work. Now for calculator stuff, you just have to write the integral. If you write this integral, you're good to go. Right? That's your work. Now if the answer is wrong and it's asking you for the exact answer, and you at least wrote this, make sure you do box it so at least I can come back and give you some partial credit for it because you did set it up correctly. So please do that so I can at least give you some credit. Okay, let's do number 16. The region R, let R be the region enclosed by the graph. Okay, we have a couple things that we're enclosing by. Y is equal to x squared, the line x is equal to 4, and the x-axis. Which of the following gives the best approximation of the volume of the solid generated when R is revolved around around the y-axis? Okay, so we're going to revolve around this y-axis. We have a parabola. We're going to stop at 4, and the x-axis, so right here. So we are talking about this shape here. And sometimes it's hard to figure out which shape, so make sure you do spend some time trying to figure out which shape, because you could be talking about this one in here, but they bounded it by x squared, x is 4, and the x-axis. Okay, and we're going to spin it around this way. Now, we could have done this using shell method, and we could do this doing washer method. And I'm going to use washer. No, I'm going to use shell because I don't want to change this. This part is not hard for me to change around. Now, if I decide to do both, we can do both quickly. But let's use shell because I think shell is a smart choice because I need to change my radius to an x value, and I don't want to do that. I'm going to keep it as a y.
How does the shape look for this?
Sure.
I have like a hard time imagining it.
So it looks like a whiskey cup or a shot glass.
Okay, so if I were to like try to do like another graph, I would just like how is it reflected across the opposite axis? Okay.
Right. So if I wanted to revolve this around the x-axis, this would just reflect this way. Okay, so let's do the shell method. I think that's going to be fastest. And remember the shell, we're looking for one cylinder, which is a messed up cylinder here. Right, that's my one cylinder. And our volume is going to be made up of infinitely many cylinders. A couple things, remember shell method is 2 pi RH integral, and we're going to do little bits of dx to give us a little bit of thickness, right? A little bit of dx here to give me a little bit of thickness here. Okay, we have everything we need. 2 pi. The r is the distance from the axis of rotation to our height, and that's just going to be some x value on the graph. X is going to go from 0 to 4. So x here. And our height is literally just the equation, right? Hopefully you guys can all see the height is just going from y to 0. X squared minus 0. I'm just not even going to write 0. And the dx. We have everything we need. In this case, it's asking us for our exact answer. Now, here's something that you can do if you don't want a decimal. Don't plug in pi. Just write 2 integral 0 to 4 x cubed dx on your calculator. And then just stick a pi in at the end of that. So if you guys have a graphing calculator right now, go ahead and plug this into your calculator and see how long it's going to take you to plug that into your calculator.
Mister, why is the radius x again?
Why the radius x? Okay, so the radius of the cylinder, okay, let me show you the cylinder here, is from the axis of rotation to wherever our cylinder's at, right? That's our R value. Okay?
Yeah.
As you can
Wouldn't
see,
that be 4?
well, it goes from 0 to 4 because I'm drawing all these small cylinders along the graph.
Oh, okay.
Right? So we end up with all
Oh,
these
so it
small
would be
cylinders, and that's why it ends up looking like this wine graph eventually.
Mm-hmm.
And that's one of the cool things is that if we can spot our R value, it might not always be X, because if I change my axis of rotation, let's say it's -1, and we still have the same graph, X is over here, sure, but we're going to X minus -1, which is now X plus 1. That's my new radius, because it's a little bit longer. Okay. So that's when we would change our radius. Now, what if I want to do this problem with the shell method? Oh, did you guys get an answer for this? Did anyone do it?
I got 128 pi.
Right, and that's actually the answer, 120 pi. Did it take you that long to plug into the
Okay.
calculator?
No, I was just doing it like
So
a second ago.
perfect. So on the calculator portion of the AP exam, if you guys are used to writing integrals on your calculator like a lot, it's really not that complicated anymore. The first time you do it, you're like, oh man, I gotta put a and b and x and all this stuff, and how do I write exponents? But once you do it enough times, let's say like 20 times at most, like you got a hang of it. You guys are smart kids. You guys figure it out, right? Right pedal is gas, left pedal is stop. Right? Definitely a lot harder. Okay, find the volume of a solid generated by revolving the shaded region around the y-axis. Okay, so this one's already set up for us. This is question number 4. Okay, in case you guys have question number 4. So they told us we want to rotate around our y-axis. Now, first thing we want to ask ourselves, since we have the picture out here, is that a disc or a washer? A disc or a washer? Hopefully you're going to say it's a disc because it's solid. Perfect. If it's solid, that means we are using our simple equation pi r squared, because these are just circles. If this was a washer, it's no fancier than pi r squared minus r squared, where big R and the R are represented by the large and small letter. Okay, all right. So let's see, we're going to make one circle. If you want to take a look at it, that's our circle. Would you guys be okay with that's my radius? Okay, and we're doing little layers of dy, right? So integral pi r, which lucky for us is just the equation here, for tangent pi over 3y, and a little bit of dy. And we're going to, since we're crawling up this way, we're going to go from 0 to 1. Okay, let's see.
We have
Sophia?
to square that though, right?
Yes, sorry, thank you. I forgot the square. Thank you. Sophia, how are you okay with the setup of this problem?
Yeah, I got this set up, but I'm a little stuck on solving the integral, like
Okay.
after.
Yeah, so did you, when you, let's see, they wanted a exact answer, right? Okay, so if they want an exact answer, let's go ahead and talk about how I could solve this. Because the answer is going to be, let me just force it. So we kick out the pi, 0 to 1, 4, and then we're going to end up with, 16, 10 squared of pi over 3y dy. We can throw out the 16 also. I'm going to save myself some time to rest, right? 16 on the outside. Now the question is, how do I integrate tan squared? Do we have any identities that give us tan squared? And I can't think of any, right? So we have to find another way to integrate this. And one way is to do this cheat, where we say tangent is equal to sine over cosine. Okay? Sine squared over cosine squared. So I'm going to try this. So 0 to 1 of tangent is really sine squared no, I'm not sure this is going to work. Sine squared x pi over 3y over cosine squared pi over 3y. And then if I try to do u substitution, will that get rid of the other guy? I don't think so. If I say u is equal to cosine of x, then du is equal to sine of x, negative sine x. And does this get rid of the sine on top? Not enough. What if I call it squared? If I said u is equal to cosine squared, du is 2 cosine and then sine, negative sine, and this does not get rid of it. So I can't use u substitution here. What if I say we have an identity rule, which is s squared plus c squared equals to 1. Sine squared plus cosine squared is equal to 1. If you remember, there are other derivatives of this where I have tangent, secant, or secant and cosecant, cotangent. So if I divide this by cosine on both sides, cosine, 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 we end up with tangent squared x plus 1 is equal to 1 over cosine, which is another way of saying cosecant. Okay, if you guys remember this identity, and if I say tangent squared x is equal to cosecant squared x minus 1, if we rewrite tangent as cosecant squared minus 1, we can simplify this to become 1 over sine of x, sine squared, minus 1. Would this be enough?
You meant secant instead of cosecant.
Cosecant. Wait.
Someone put that in the chat.
Thank you. You're right. Let me think. So is there a way for us to secant squared the derivative of tangent is secant tangent, the derivative of sine, I'm trying to remember. Pi, integral from 0 to 1. We wrote tangent as secant squared x minus 1 dx. Integral of secant squared x dx is tangent of x. Okay. If you guys remember, the derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared, the derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. So from here, we can say pi, 16 pi integral from 0 to 1 of secant squared x minus integral from 0 to 1 of 1 dx. I think that's right. Did I mess up anywhere? Of course, I need to write down all the variables. Pi over 3y, right? Pi over 3y. Darn it. Pi over 3y. Okay. Then we're left with 16 pi. That's tangent of x. A tangent of. Okay, so we have, because we have this, we have u substitution. U is equal to pi over 3y. Du is equal to pi over 3 dy, and then we're left with du over pi over 3, right? So we have to write 3 over pi, tangent of pi over 3y. Derivative of tangent is secant squared pi over 3 y, followed by chain rule of pi over 3, which gets rid of that pi over 3. Then we're going to, show you in the parentheses, minus this integral here from 0 to 1. Oh my gosh, it's so messy. I'm sorry. 0 to 1. And then on the right side, that's just going to be integral from 0 to 1 of y, right? Darn it, what am I doing? That's just y plug in 0 and 1. 16 pi. If I plug in a 1, what's the tangent of pi over 3 times 1? And what's pi over, what's the tangent of 0, right? If I plug in 0, it's going to be 0. So on top, if you remember the unit circle, pi over 3 is 60 degrees. 1, 2, square root of 3. The tangent is square root of 3 over 1. In a 0 degree triangle, 0, 1, 1 triangle, tangent is 0. So we're left with 3 over pi. The tangent of 1 is square root of 3. And then in the back, minus 1. Is that the answer? I feel this is like crazy. Exact answer. So my exact answer is, let me plug it in, 16 pi times 3 square sqrt, nope, 3 square root of 3 divided by pi minus 1. Oh my gosh, that's the right answer.